So, welcome back to this video. In the last video till this part, we have learned how to calculate the error in a machine learning model, how we can state that the particular model is best for the given data, for especially for the linear regression means there are linearly regression, there are two variables that are linearly increasing or are decreasing with each other having a correlation at a extreme level. Okay. So in this video, we are going to do the practicals of the things, how the things are going on in Python. First of all, let me tell you about the topic. The topic is simple linear regression. Now what we are doing to do is, first of all, let us load the data and analyze the data, what the data is, what is saying. I have already coded everything for you, not going to code line by line in this video because it takes large time and we have to cover the large part in smaller time. Okay? Because time is very precious. First of all, I have imported warnings. Warnings is a library in Python that will ignore any kind of warning that are given to you when you are going to run this field. Sometimes a large text will come onto your output. That's nothing, just because the warning that this package will give certain warning in the try and exception catch that are going to work in the background. After that, we have imported two libraries, some NumPy and Panda, basic two libraries, and have imported the dataset which while using the read CSV. I am using advertising.csv. If you want the data link and also need this resource file, let me pin me in the comment section. I will share you. Okay. After loading it, I can analyze that there are some data related to TV, radio, newspaper, or sales. So that means there are users who are using TV, there are users who are inhaling the service of radio, newspaper, and sales. Okay, that's fine. Let's expect the columns of the variable for expecting the columns of our variable data set, but we are using the shape method that is present into our Python. Then what info will give us? Info will give us the basic information about our data set, that how many null values are present in a particular column. So you can say there are non-null values and are of type float. Okay, now what is described? This is the basic things of exploring our data. First step is exploring the data whenever we want to create the data model. So dot describe method gives the statistical information, means how many count is there, number of columns, the mean average of all the entities present into my data set, standard deviation, mean 25th, 15th, 7th. Right? It's a very important concept. It is interquartile range, means major output or the major data is in between a normal graph. Okay. Have you ever learned about the normalization? This just give us that if we tends our mean to be zero, the inputs are spread into a bell-shaped graph. Okay. And the output that are beyond these ranges are our outliers. Okay. So this is the basic feature that we can handle through our outlier function. Now, the second step that we come to know is visualizing the data, how we can visualize it. Linear equation means we have to showcase the data into a scatter plot, that how much data is scattered. I have analyzed it through pair plot, or you can use Seaborn dot scatter plot and given the column name, 2x is equals to first column name, y is equal to second column name, and just gives the scatter plot. Okay, otherwise the second method is by using pair plot. Now after visualizing this, you can see that there are three graphs. I can clearly see that there is a best fit light that can be linearly best fitted. It means the first graph is the best linear equation that can be. It also be a linear, but the data is far spread. It means variance is more than this one. It's having a good variance. Variance just is spread of the data that we have. But if we draw the residual line, these points are far away from the actual point, and this is called error. Now, when we will train our model or will expect our output, we have to just check it on the basis of our residuals, R-square or RSS or mean square error. Okay? Now, why I am using heat map? I already told you we have to analyze the correlation core function. I already told you in the last video that core method is helping us to know the data of core correlation between two variables, and I have analyzed the correlation here in the heat map. Anode means we are going to show the values over here. As is the visible from the pair plot, heat map, the variance TV seems to be the more correlated. I already stated that. Now we have to do the simple linear equation. Why I have analyzed with the two variants that there are high correlation means there are linear equation. In any data set, first of all, find the correlation between two numerical columns. If you have two numerical columns and you think that they are interrelated to each other, just find the correlation. If the correlation is forming the linear regression or the linear equation, then we can perform simple linear regression. Okay. The equation of line is y is equals to mx plus c. So these are all the data which we have already covered in the last video. Now, which two columns we have to analyze? First column is TV and the second model is state. First of all, the first step that we are going to do while making the linear regression, there are two methods to train the model. First one is the deep statistical analysis and the second one is basic linear regression model. First of all, we will see that how we can make the linear model using a simple library, statistical library that will give us the wide range of the output. मतलब ये कि दो लाइब्रेरी है, एक लीनियर रिग्रेशन सिंपल मॉडल के लिए, उसमें सिर्फ हमें हमारे पास दो वेरिएबल मिलेंगे और दो वेरिएबल से हम अपने मॉडल को टेस्ट कर लेंगे. देयर इज अनदर वेब वेरिएबल जो कि स्टैट्स में आती है, एसटी स्टैटिस्टिकली लाइब्रेरी होती है, उसमें हमें सारा आर स्क्वायर हाइपोथेसिस का पी वैल्यू क्रिटिकल पॉइंट सब मिलते हैं एंड वी आर गोइंग टू एनालाइज थ्रू इट एंड वी कैन डू परफॉर्म बोथ द मेथड्स, बोथ द ways how we can analyze the output. Now, first of all, when we have the data, we have to train it. Now, whenever you want to train your model, you have to maintain a ratio of 70-30 or 80-20. What is 70 means you have to give the 70% of the data to train the model and the rest 30% of the data to test the model. Okay. Now, I have imported one major library that is Scikit-Learn.model.selection import train test split. But it's mean it is meaning that from this library we have to import the module model selection, means we are going to do the model selection, and I'm importing train test split means we have to split the data on the basis of training data and on the basis of split data. There will be four outcomes that are going to come up from this function. First will be train data, test data, y train and y test. Then simply call this function on the x and y. Then size will be specified that 70% will be of training data and 30% will be of testing data. Random state is equals to 100 means random data it can take. Okay. Now, after I have taken the data or splitted the data on the basis of train and test, I have come up with the x train as the data given here. Means this is the TV and this is sales, and this part of data is now under the training the model. Okay. If I talk about the Y train, then this is the data that is under the Y testing. Now we have to make the linear model. For making a linear model using statistical way, we are using statsmodel.api. This is a library into Python and has SM and reported as alias as SM. Okay. Now we have to make an important observation. What is the observation? Whenever you write the equation of line, this is the equation of line. Why line is important? Because linear regression means there is a basket line that are going up in a particular direction. When there is a line in linear regression, you can see you have x, you have y, but what is c? C is a constant variable that is added to our lines to make a proper line, proper best fit line passing through our data. But it's extra data that we have added into it. Okay. We have know that the line of equation is y is equals to mx plus c. C is a constant, I already do. So sm dot add constant method is doing that it is going to train on this x data and are going to add a situated c value into our data. Means originally we have x train slope into x, but we don't have the value of c. So this function is going to add c into our data. Then After that, we have to create a model. So OLS is ordinarily least square attribute of stats model that is going to create a linear model. Now it's creating the linear model, but on which data? It is going to create the linear model on the X data having the constant and the Y tray. We are going to train the model with the help of X data, with the help of Y data, and are going to fit that model on the data. After fitting that model onto our data, we are just going to explore the data. There are many parameters. We are just going to use the params function method, and it's going to give all the parameters over there. And it's given us the better parameter. First of all, parameters are the value that of the line. The parameter that we have to find is the m value. We know c, we know x, we know y train that is expected, but what about the model that had given? Now the model state that the slope of these values are given by this method. This constant had been given, and then slope is given as 0.05456 is the slope of our line of the equation. Okay. Now, if we want to perform the summary, this is a statistical summary of our model. Now, summary function is going to use over there and are going to give the summary of our model. Now, the model is OLS. With the help of OLS, now these have all the parameter on the behalf we are going to judge our model. I already showed you the R squared. R square value is 0.816. It means it is very well, because more the R square value, more best model we have into our hand. It is the only way to judge the best model into our data. It's already nearby one. It means the best data, or we've already seen it with the help of scatter plot. Just we have to prove it. We can't just give the assumptions. We have to prove that assumption too. I have proved that there is a linear line into TV and sales and have a great correlation with each, and have been proved with R squared value. Okay, adjusted R square value. What is adjusted R square value? I will tell you in the next lecture. This is basically a point used in multilinear regression, where we are dealing with multi-correlability and everything in the next lecture. F statistic. F statistic means are related to hypothesis testing. In hypothesis testing, we are assuming that the null hypothesis saying that there are no change into the data and no linear regression exists into two variables. They are all same or having no relation with each other. But the null hypothesis says that there is a linear equation between both the variables, and we have to deal with that. Okay. So for accepting the null hypothesis, and for rejecting the null and for accepting the null, we have to prove that the f statistic value must be less than some alpha value. For from f statistic we will come to prob f statistic. It will be 1.52 e minus 52. It will gives to be nearby less than 0.0000 something data is there which is very less than 0.05. It must have to be less than 0.05 to accept the null hypothesis. I hope it is clear to everybody. And this is coefficient, standard error is there, t value, p value is there. For statistic analysis, I already told you 0.000 something value is given by the p. Okay. Now skewness of the data also have given by this model and everything. Coefficient and significance, p value, r square value, we have to check. F statistic, I already told you these are the parameters we have to judge for our model over there. Coefficient is 0.054. It can be cleared over there. See 0.054 because we are dealing with TV. Then F statistic, R square value is 0.816, which is really good. 81.6% accuracy in our model is there. Now, when we are going to perform EDA on our model. Now I am going to perform EDA on the model. Now whatever we have trained our data, the data set on which we have trained the data set, I have just performed the analysis with the help of scatter plot, and I have performed it. In the starting we have X train and Y train. But what is Y train now? Y train is the actual real value. Okay. Now scatter plot. Y train is the data that is given by our model. y is expected by our model, but this is the actual value that our model will give. Now residual analysis we have to give. How to do the residuals analysis? We can do the residuals analysis by using the predict method into our OSI. We have created the model with the help of OSI. Now have predict method is going to predict the value of y on the behalf of x train, and are going to take the difference of the actual y train and the predicted y, means actual y was the taken from the train test split. The train test split the data and given us the y, and the predicted value has been predicted by with the model dot predict, and have analyzed that all the residuals and then have plotted it over there. Now you can see the assumption of linear model. Whenever we are going to make a linear model, we are taking in that assumption that errors, the residues are always normally distributed in the bell shape. Means whatever the errors, whatever the residues we have, they are already in the bell shape. Now we can also plot the scatter plot over there. Same predict, we can use add constant. We now whatever we are done with the train test, we are going to perform same with test. We have trained the model very efficiently. Now we have to test it. How we can test this? Now whatever we have performed with the train data set, the train x, now same doing with the x test. Now going to take the output of train and going to take the output of test, and are going to check that error in between. Okay, now I predicted the value of y predicted from the text. Now there are two libraries that are called mean square error and R2 score in Scikit-Learn.matrix. We have to use two parameter, Scikit-Learn model selection for train test split, and matrix is used for checking the model prediction. Now just we are going to do is mean square error is going to give us the answer in the square format, because y predicted minus actual y square over the n is the mean square average error into our model. We are just taking the square root. Okay. Now mean square error function will tell us the error between y test and y predicted. What is mean? Means y predicted from the actual training data set. We already know that now lr dot predict. Okay, LR dot predict y test and y predicted, means whatever you have predicted from the test data set using model dot predict versus whatever you have in the actual y test when you have split the data, how much error was there. Now same we have to check for R2 square. This is the second way to check it. Otherwise you can just make that L2 dot model dot fit model, then fit osi may given x test y test, and then give fit, and then summary it's going to give us the summary. This is for training. We already trained it the LR on the basis of OSI. Now with the help of trained data, we are just predicting the test data. We can visualize this part best fit line. Now these are the way to do the prediction on the behalf of stats model library. Now how to do same with the linear model in Scikit-Learn? We just have to import model selection, import train test, just simplify the training data, test data, everything we may say. Instead of stats model, now what we are doing is we are just importing the linear model from linear regression. This is the simplest way for performing linear regression. We are not going to do with OSI in every time. It's going in deep learning and deep analysis, but in simple ML model, we are just going to use this. We have imported linear regression, have prepared the linear regression, have called it like OSI. We are just making the model. We have just called the model with the linear regression and fitting the data on which behalf we are fitting. We are having fitting the X train and Y train. Now in the OSI, we are just going to do this model dot parameters. We are go params function method is used to give the parameters, the slope value and the constant value. It's given by the intercept the coefficient function method in the linear model. Okay, so it's given by there. Now these are the basic questions over there. What is good RSME and everything, the basic question answer I have put over there. If you want to learn, you can just comment over there. I just give you this PPT into, or the notebook into you in the description. I hope this is the basic data or basic thing, because understanding is more far better than memorizing the code. If you have understand it very well, you can be do these things by your own. Just have a look on this video again, watch it again. If you have an error, just put your question in the comment box. Till then, keep learning. Bye bye.